Take a look at a number of different forms of powders based on the production method. The next few slides will show variations of ferrous powders. Here you see a stainless steel that is gas atomized. The bar below shows a 10 micron reference. In gas atomization, you basically take a melt pool, you force it through a nozzle with a cover gas involved. And as those droplets begin to cool, you begin to get these nice spherical shapes. Water atomization is another technique where instead of using a cover gas, you quench those droplets with water stream. That can lead to a highly irregular surface and a highly agglomerated surface as well. Changes in atomization conditions and tweaks in technologies have allowed for water atomization to also produce more rounded powders than is commonly seen in this case. But you begin to see based on these agglomerates, you can get a lot more coarse particles. Carbonyl ion. So this is through a chemical vapor deposition method where iron pentacarbonyl is decomposed as a chemical and you have a nucleation of iron atoms that begins to create these nice spherical particles. If you take a reference and compare it with of this size bar with the gas atomized powders, the water atomized powders, you can see that there is a potential to produce much finer powders, typically 3 to 5 micron average particle or median particle size using the carbonyl route. Because of this nucleation growth mechanisms, if you section any of these powders, oftentimes before annealing, you will see that you can see these growth rings as new layers of atoms begin to grow around the core and you end up getting this type of a structure. Sponge ion created by electrochemical uh, methods can be shown over here in contrast to what you've seen earlier. These are highly irregular in shape. In addition, taking a cross section indicates there's a high level of porosity as well. Okay, these are also much coarser powders in addition to being quite angular. So these are sponge ion powders provided by electrochemical methods show a high level of porosity. They are coarser powders and are more irregular in shape. Angular powders are again provided by mechanical methods, and you can see some of these kinds of shapes that are created in this method by doing a post-processing called jet milling, where the powders go through a confined chamber in a airstream. They are able to get a more rounded morphology based on attrition, based on collisions against each other and the wall. Centrifugal atomization involves atomization followed by not just a gravitational process, but in centrifugal atomization, you end up getting spherical particles as well. But as you can see from the reference bar, they tend to be a lot coarser. Electron beam melting is one type of process which requires coarser particles in its use. There are nanoscale fabrication methods, and here is an example of the scale bar. You can see it's about each of these particles are in the range of 100 to 200 nanometers. These are again synthesized by chemical methods. Here's an example of splat quenched ribbons. This is an iron neodymium boron material used in magnets, and you can see thin shattered sheets, much coarser in diameter.